A very good evening to all and assalamu alaikum. As promised, we are coming up with COVID-19 live data analytics on the data set. I kept on searching for data sets, right? And I could not find. Anyways, I found one on, that kaggle.com, right? So kaggle.com. I found some data sets here. So we'll try and analyze the data set which is available, and I've downloaded the data set, and I'll keep sketch and data set. You can download it down in the description section. You can go to the description and download it, right? You guys to be very attentive, as you guys might not be aware of all the techniques and all the methods that we are using here. But do not worry, we are going to touch all the methods and basics separately in the upcoming lecture, and we'll try and divide this because analytics might take too long, so we'll divide it into two parts if possible. I'm not sure about the time it's going to take, so we'll try and divide it, right, if it takes more time, right? So without wasting much of your time, let's get started. We know that the first thing first, import pandas as PD. And second thing that we'll be using today is we will be using NumPy for analysis. Okay, let us not use it today. Okay, let's import Seaborn for data visualizations as SB. Right, and let me quickly Seaborn Seaborn and as SB. Okay, let me quickly import the data frame. So I'll say df is equivalent to pd dot. I have a CSV data set, so I'll be using CSV. So I'll say pd dot read underscore comma separated values, and let me increase the zoom. Oh, how can I forget? So let me increase the zoom in here so that you guys do not face any problem, right, in data visualizations and also in visibility. Now it's more visible. So let me import /my files, right? So my files folder has actually become the destination for all the data analytic files. So COVID-19.csv. Right, so the first thing first, imported. So let me do df.head. Right, so let us analyze the header here. Right, so we can see that we have the date, we have the country, and Afghanistan, because it starts from A, it's automatically sorted here. And we also have the province, state, which has some NaN values. Let's see how we can deal them. We have the latitude and longitude if you want to draw those map values, right? If you want to use Geopandas for geographic locations, and we'll see that how many are confirmed, how many are recovered, and how many are dead. So this is the data set that we are going to be using, or this is the data set we'll be dealing with. So let's start with the first thing, right? So let us analyze all the columns. So df.columns. Okay, we can see that we have the slash here. So the slash is going to cause some problems in data analytics. Anyways, date, country, region, province, lat, long, and confirmed and recovered are the column names available with us. So now let's go ahead and correct the columns, right? So the first thing that I'll do, I'll say inside data frame we have columns. So inside data frame we are having columns, and those columns are of type string, and I want to replace, right? What do you want to replace, right? I want to use regular expressions, which is R, regular expressions, and I want to remove slash. You can do a normal str replace without using regular expressions. Right, so you can say this, I want to replace this with this, right? I want to replace slash with nothing at all, right? So let us see, right? Now you can see after you do str replace, you have removed, right? So but this is not what we have to do. We have to assign it to a specific column. So what I'll do, I will say df, because if I run it now, if I say df dot head, so because we have not replaced the columns, right? What str replace does, you know basics of Python. Str, string replace, will return a new string. right? And now you can see the country, region, state, province, they remain unchanged. So what we are going to do to cope up with that, what I will do right here, I will say df dot columns is equal to df dot columns. Now simple variable declaration and some variable stuff that we do always, right? Okay, let me just increase a bit of, right, so now it's more visible, and we will do the normal stuff, right? Normal stuff including that we are assigning back to columns, right, after replacing slash with nothing. So now we have replaced the columns, and now if I do a df dot head, and let me display only one. Now you can see our data frame is having the replaced column name. So first thing is done. Let me go back and do some analysis, right? And let us see the shape. So I'll say df dot shape, and now you can see the shape. Shape is a function, I suppose. No, it's not this function. So it is sf.shape, df.shape. Look what I do. Okay, 18,576 rows with 8 columns. 1, 2, 3, 4, 5, 6, 7, 8 columns, and 18,576 rows are available in the data set, right? And you can even see the index. So we'll say df.index to check. Right, so it starts with 0 and stops at 18,576, right? So you can even see the index, and you can even see the types. If you want to see the data types, you can see the data types, which is d types, df.d types. You can see that we have floating variables. Latitude and longitude is float, and depth is also float. That's why you see here 0.0, 0.0, right? Why do you see point? Because they're all of type float, and countries object and others are float, right? Because we need to know what we are going to do analytics with beforehand. Then we can do analytics like a pro. Right, so let us see first df.is NA. So let us get rid of NA values first, because this is the cleanest data set I found, right? But still it's having more. Province and state has 12,816 NA values. Recovered has 1008, and that's 72. Confirmed has 72. So what we are going to do, we cannot do anything with the confirmed and recovered, so it's going to cause problems in the data set, right? So what we can do, let's call seaborn dot heat map. Let's draw a heat map, all right? And I want to see in the heat map all the values which are null, and let us say x tick labels. I want x tick tables to be true, and I do not want y tick labels to be false. And CMap, my favorite, as I told you in the previous lecture, is Verdis. VIRIDIS is what my favorite is. So my favorite is also an error. I do get these errors regularly. So sb.heatmap, cborn.heatmap, and I want to get df dot, that is data frame is null, and that's absolutely, and then we have x tick labels is equal to true. And why the hell true is in quotes, right? That was the error. No, we still have an error. ytick.labels is equal to false, and we have cmap is equal to, what is the error? Let's see the error. We are getting x's error. Oh, we haven't written unknown property ytick labels, right? So xtick.lab, okay, ytick.lab ELS labels is equal to false. Yeah, label spelling. Oh, we can see province state has some disturbed, and to that recovered and confirmed also has some disturbed values. Now you can see the heat map. It's showing some null values in here. So let's do what we can do. Let's say data frame dot fill any. I want to fill any of any, and I want to target this recovered here. So you can see recovered can be dealt with, so I'll say recovered, right? And I want to keep instead of any, because that's going to cause problems in data analytics. Right, I want to replace recovered with, because it's a floating value, so I'll keep 0.0 in place is equivalent to true. And the second thing that I am going to do is I want to fill any, because any is in province state, right, and it is in province state. So let me copy the column name. It's here, province state. Alright, so I want to fill province state with u unknown. So I want to keep there unknown. So I'll say in place is equal to true. And the third thing that I want to do is, let me first draw the heat map here and see how does the data set look like. Okay, now the data set is quite okay, so let's not do anything with confirmed and recovered. Let's try and ignore, and after that first we get the results, and then we say we will apply median or anything, and then we'll say how it goes after we basically do our analysis, and then we'll see the difference after the analysis and before the analysis. Since we have not been able to do, or we haven't done any analysis, right, so we'll not be able to compare before and after analysis, right? So in order to do that, we'll have to complete the analysis process, right? Alright, so we have been able to do this now. Analysis is right. So let me try the f dot head again and see what do we get. Yeah, unknown, unknown, unknown. Our province and state has nan values. Now we have unknown, so that we can query them. How many are unknown and how many are known. Alright, so let's go to next line and do. Let us say number of cases till date. How many cases are positive till date? So let's call this cases per day till date. A very long variable name, but it does make sense. So I can call df, which is my data frame, and I'll extract, and I'll say I need to group everything by the date, right? So group by, and I have this date column here, everyday cases. So I will say group by date, and I need to transfer, because I am assigning something to cases per day till date. So I'm assigning something. So what do I assign? Group by date, right? Create a group wherein all the dates are present, including confirmed. So we have this here, including confirmed, right, and including let's say about deaths, and including recoveries. So we have recovered, right, and we have let's say about deaths here, right? So let us say, what do we get? Okay, let's echo it out, cases per day, because we are transferring, we are not printing anything. So let's print it out. Alright, so it's not going to give us anything. Group by date. So let me see. If I do something like this, dot max. So I want to see the maximum cases per day. Now you can see this here. Confirm date 22 January 2020 had 444 and recovered by 28, and that's where 17. And as we move ahead with all the dates, you can see that the number of cases increase and the number of deaths also increase. All three are increasing: recovered, deaths, and number of cases. As we move, it'll keep on increasing. So we are showing only 72 rows. There are many, but 4/2/2020 had 2,43,453 cases with 13,915 deaths and 63,471 recovered. Right. So this is what we are getting. Let me basically do one more thing right here. So let us hide it, and let's not do this because we have already seen this. So let us say we want to get number of cases till date. Let us say max is going to give us that, so we already seen that, so no need to have it. So I'll keep it thereby so that once I document it and create a sketch for you, so I don't miss this out, right? So we can do cases per day till describe. I want to describe, and once we run describe, you will see that you are getting every single thing right here, right? And cases per day has minimum, you can see 25%, and you can see maximum at the end of the day. So once we run describe, all right, and okay, let's do one thing here, because it's not going to show us results this way. So let's say cases per day. Let's say cases per day. Okay, let me run it again here. Alright, so let me run it again before describing. So let me run it again for you, and I'll say dot max. Right, so what am I doing right here is I say cases per day till date will have grouped by date, and it will take columns like confirmed, that's and recovered, and I want to get the maximum number out of it, right? Max means you are going to get only one number, right? So that is going to get transferred, and then you are going to describe. So now you can see that the maximum deaths we are having is 3915 and the maximum are this, and recovered are this, and 75% of the same is this, 50%, 25%. Minimum deaths a day are 444, minimum confirmed. So far, minimum confirmed in the data set of 444. So we don't have a confirmed number below 444 a day. And minimum number of deaths per day, we're having 17, and recovered we are having 28. So, right, so this is 75%, and we have the mean and count of them. So confirmed are this, deaths are these, and because count is going to show us the same thing. But what we are more interested in this max, and we are going to see minimum. Even if you run it manually, right, if you're not sure whether this describe is giving us the right thing, which it should give us, right, the right thing. So we can say, let's say if we can count a plot here, then it would be better. If I call cborn and then I say count plot, right, and I will take it on X label. So I'll say X label is equivalent to confirmed. It is going to give us, and hue on the left side on the Y label is going to be death. So I want to see the number of deaths, and data is not the data frame that I'm going to give. I will give the data frame as cases per day till date. Now, if you want to see that first, so let me show you this. So CASES, cases per day till date. So let me print it for you, right? You can see this is cases per day for you, right? And now if I supply this as a data set here, data is equivalent to cases per day till date. Now you can see a count plot here. Okay, we still have an error, invalid syntax. X is equivalent to confirmed, C is capital, hue is equivalent to deaths, and there is no comma, and data is going to come from the cases per day. So let us draw and wait unless we have a count plot. And this is going to be very scattered count plot right here, because the data is huge. We are not handling small data this time as usual. In Titanic, we didn't handle big data, and in other analytics, we did not handle big data. It's somehow not too large, but yeah, you can see it is bigger to some extent. Now you can see that 17 deaths, right? You can see this here. So recovery and death is happening at the same time, and the chart is so big that we'll not be able to see it. We'll draw some other plot here, but you can see 17, 24, 40, 52, it keeps on rising. So we are able to see that the number of deaths are rising per day, right? You can see there's a number of deaths are rising. So this is 3 months data, 3915, maybe 2 days before yesterday. It's I'm doing analytics on 2nd, maybe the data set of 2nd of April 2020, and now you can see that it's rising. It started it started from 17, and then it kept on rising. All right, so because we have supplied deaths here as hue, you can supply confirmed, you can supply deaths here as well, right? But this plot is not going to show us the reality. I'll keep it there only for you so that you can, once I document it, you'll be able to see that. So let me see cases per day. Let me have matplot. Have we inputted matplot? Okay, let us see that. Okay, let me import one more thing. Import let me import matplotlib dot pyplot as plt. Okay, I'm importing matplotlib, another data visualization library. So I'll be importing it as plt. You'll see them in great detail once we take them one by one, so you don't worry. So I'll say cases per day. Please draw a plot, right, of this, and kind is going to be, kind is what you want. You want line, you want bar. So I will say kind is going to be, let us say that kind is going to be, let's say bar here. So kind is bar, and let me give a figure size. So I'll say fig size is going to be 30 or maybe 50 by, let's say 50 by 10 is going to be the figure size. So plot, what is problem? Fig size is equivalent to here, right? So it's coming, it has come. Now you can see that, you can see the line. If you draw the line, all right, if I take and draw a line like this, let me take it to MS Paint and see what is happening. All right, so you can see clearly here. Let me draw a line. I can do a scatter plot for you as well, but since we have to manually see what is happening right here, so this is going to be your plot. I don't know, because since I downloaded this data from that Kaggle, so I don't know why is it going down here. It should not be, but yeah, since we have downloaded it, not sure about the accuracy of data. You can download yours, right? So now you can see, but still you can see right here where it started all from. Maybe we did not have data available right here, but you can clearly see that the height it has taken. Now if I draw a linear regression line, or maybe a linear line here, so you can clearly see that it is rising, right? So this is the rising edge that we are seeing. So this is the technique that we apply in machine learning, linear regression, and maybe multivariate regression or single variable regression. It doesn't matter. Okay, now you can see this orange line which is here, and now you can see that it's rising. You can clearly see the rise that it has taken. Now if you want to predict anything, prediction will happen. It's going to be rise over run, or maybe other techniques like we have rise over run. We have some linear regression techniques, like we have many different techniques we can apply here. We can apply the nearest algorithm. We can even apply k-means here, so no problem to predict. So prediction is going to be in some other lecture. I will surely develop or maybe recorded video for COVID-19 predictions, how many recoveries and deaths, and how many are going to be confirmed till let's say about May 2020, so that we can there apply linear regression techniques, right? And we can apply the nearest neighbor also. So let us see which technique is feasible and which techniques gives us better results, so we can apply that techniques as well. So we can apply any technique, but we'll have to see with the least squared error, right? So now, have you seen this? So it is clearly rising. So now if you want to plot more to see what is happening, I will show you that also, right? So there is no problem in that. Since we have imported our matplot, let me go ahead and start here with the next line. So it's too much zoom. Okay, so it's okay now. So let us say plt, because we have imported matplot.pyplot as plt, right? So I'll call plt, and I can say .x label. Let's say plt.x label is equivalent to deaths, and let us say plt.y label is equivalent to, it's a function x label and y label, so it's going to be, because confirmed are too many, the deaths won't be visible at all. I don't know, right? So, but yeah, still we can scatter a plot. So I'll say plt dot scatter a plot for me, and I want to give you cases per day till date, right? And I need to see deaths versus cases per day, right? Confirmed, right? And I want to see that. All right, so we have some problem here. Scatter plt dot xlabel ylabel, because we are using inline, we are writing many statements. So what we need to do, if you are writing more statements, so I'll say using matplot inline. So I'm using it inline so that it is, yeah, line magic function matplot not found, matplotlib. It is not matplot, it is matplot library. Still the error does not go. So let me see the error first. plt.xlabel is equal to deaths, and what is this terminator doing here? I don't know. And then ylabel is equal to confirmed, right? And we have cases per day, deaths, deaths, and then confirmed. So let me try. Yeah, now you can easily see. Let me change the color here for both. So I'll say color is equal to red, so I'll use red color. And if you want to change the marker, so I'll say marker is equal to any marker. So you can use dash as marker, you can use star as marker. Okay, I have made a mistake. Color is equal to color is equal to red, and marker is equal to maybe star, any marker. Okay, we still have an error. Okay, let's say confirmed, and then we have color, color, color is red, and marker is M is small, I suppose. Okay, M is not capital, M is small, so it's case sensitive. Right, still we are having an error. Let me go with plus marker. Yeah, plus works and dash does not work, and even star can work here, and it's going up, and deaths as usual are not visible because the number of confirmed cases are quite high. And now you can see it's taking peak. It's taking peak. What we say in machine learning, anything to come down has to reach to its peak, right? So we'll find the peak, and we'll find the appropriate rate at which it's growing, and the maximum duration of time that it will take to come down. We can apply certain machine learning techniques, but since you have not started with machine learning, so it is not feasible to talk about ML here. But yeah, you can see it's rising, and it is rising, right? And what we have seen here also, the rise is happening here, the rise is happening here, and we can see many more things, right? The rise is not the only thing. And my favorite plot, if you want to do comparison between the number of deaths, you want to do comparison between confirmed deaths and recovery, so you can also do that, right? So we have this already. Matplotlib did not work, so we have already this cases per day till date, right? We can also say please plot for me, and this time the kind is not going to be bar, the kind is going to be line. Give me a line. Kind means this, right? So the visualization that is happening here, because kind was bar, you saw bars, now you can see a line, just like I draw a line. So these were bars, kind is bars, and I draw the line, and line is here, right? So that's the difference. So this time I'll be using line, and I will be using figure size. So let me use a bigger figure size, is equal to 40 into 10. So I just forgot is equal to, otherwise it would give me an error. Okay, now you can clearly see what is happening here, and you can see if I zoom, blue is confirmed, orange is deaths, and green is recovered. Confirmed is blue, death is orange, and recovered is green, right? So you can see recovery is happening, right? And deaths are quite low, but yeah, they are growing. Death rate is also growing, and recovery rate is also growing. And you can see, apart from all the apart from everything that is growing, we'll have to remember that The major case to worry about is that you know, the number of confirmed are also growing. So let me take this to paint and draw a line and show you a new line versus old line. So this is the line that computer draw, and this is what we earlier draw. So let me do a comparison. You can see this here. You can exactly see here something wrong with the data set. I'm not sure this should happen. We do not have any scope of this, right? For 5 days you didn't have anything, I don't know. So since it's Kaggle data, so you can find much better data sets, they're available. Next time we'll do analytics on India on a much better data set. But yeah, you can see here the line is doing the same thing, and it's at times going down. I don't know why it's going down here, but yeah, you can see it's rising. Even if I draw a linear regression line, you can still see the line should be like this, right? So it is growing. This is where it started from. There, this is where it is today, right? I hope you're going to understand, and you're understanding it like pro, right? So this is the figure. We can even change the kind. If you're not understood what kind is, I can change the kind from line to bar, and you will see the line being replaced with bars, right? So all 3 bars. Now you can see the bars. So this is you know, these are the deaths, and these are recoveries, and these are number of cases, right? So you can see deaths, number of cases, blue line, and you know, recovery is green line, and deaths is orange line. So this is once we convert it to bars, right? So kind can be anything, right? So you can even draw a scatter plot if you want to draw any scatter plot. Alright, so let me do some analytics. Apart from visualization, we should be able to get out some figures as well. Alright, so let us say cases per day. We already have this cases per day till date. Alright, let me have a smaller variable, cases per day. So I'll say cases per day. CPD is equal to cases per day. Alright, so let me go ahead and say CPD, and I want to see how many are confirmed. Alright, so I'll say these many are confirmed, but I don't want that. I want the maximum. So I'll go with the max. It'll count all and give me the maximum. Confirmed are 2,43,453. So let me take it on and say I want to get deaths per day, but the maximum of that. Deaths, so that's 13,915. If you just get rid of this max, you can see day-wise deaths. So this is day-wise deaths. So you can draw a count plot of this as well. Right. So what you can do that. So you can say now you can see the count plot for deaths, right? This is see that you know, and you can say recoveries. You can do the same for recovered. Alright, you can see the recovery is also happening very fast, and confirmed separately. You don't need to do everything at the same time. You can see now you still have this bucket down here. I don't know. Okay, right. So since you have got, so now what we can do right here, we have this max, and we have the dot max. Confirmed is seen. I can say deaths max. I want to see maximum deaths, so which is here. Maximum deaths is already displayed. All right. So I want to get recoveries. You can see 63,471 have been recovered. So let us see maximum cases. Date for the maximum number of cases. Please give me the date of maximum number of cases, right? What is the date of maximum number of cases? When did it happen? So I will say CPD, and I can say maximum number of cases is going to give me CONFIRMED, and I want to see the max. I will say IDX max. Please give me the date, right? and now you can see 4/2/2020. Oh, just what is the day today? Oh my god, 2 days before, right? It was maximum case. I never know. Did you know? No, you did not know as well. I didn't know as well. So let us see the minimum. Okay, if you are seeing maximum, when was it? When maximum number, what was the date when minimum number of cases were recorded or registered? So MINIMUM. So it was minimum number of cases were recorded on IDX max. Why would I go IDS min? Right, so 22 January 2020. How many? So we'll see that how many were recorded, and we know that minimum is 444 and maximum is I suppose. So let me see that first. What is the minimum? Right, what is the minimum? So I can see CPD confirmed dot minimum cases. I can see 445. I told you. And let me see maximum 13 something. Maximum deaths, okay, confirmed, so I don't have to go for. So let us say maximum is let's say deaths, so we know that 13,950 is the total number of deaths, and minimum we having 444 confirmed cases CPD. Okay, that is the minimum, and this is the maximum. Right, so far we understood it, right? So we don't need to right, so okay, let us see number of cases per country. So number of cases per country, right? So what are the number of cases? I'm just in habit of pressing control and enter for almost everything that I write. I press control enter without even knowing the outcome of it, right? Okay, let me call the data frame. Imagine now I'm not calling CPD. What is CPD? CPD is number of cases till date. What is number of cases till date? So you already know, right? So what we did here, we grouped by date and assigned confirmed deaths and recovered to this. Right, so this time number of cases per country. So this does not take countries, right? So my CPD does not have countries. It has three things: confirmed, death, and recovered. So country is not there, right? So since country is not there, I'll have to do another group by. So I'll say GROUP DF dot group by, and this time I will be doing the group by taking COU and TRY. What is that? I don't know. Let me do DF dot head 1. Okay, so it is country region, right? So I'll copy it. DF dot group by country region, and I want to get one. Let's say about I want to get confirmed. I want to get confirmed, and I want to get deaths country wise. Imagine it was by date, group by date earlier. Now we are doing group by country. We are grouping everything in a single country now. So we have recovered, and we know that we have to take max, otherwise we are going to get day wise results. So we'll do the max, and we are getting this max right here. So let us see. Alright, so let me not do this since it's already done. Okay, I'll keep it for you here. df.group by is done, and let me do two different things right here. Okay, let me fire it up. So now you can see it's country wise, confirmed deaths, right? Recover, it's day wise, right? Confirmed cases and deaths, right? So you can even search for. I can search it. I can search that in. Using using the map also. I can draw a map. We can use Geopandas for that, and we'll be using Geopandas for that. And now even if you do not want this only, let's say about, I say I want number of cases per country. I'll copy this number of cases per country, and if you want two columns, you can get it by two columns as well. I want country and province as well. So I'll just give it a comma here and give results as per province. Now you can see provinces unknown, 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 and now some provinces are present here, right? Okay. So this is what you can also do to group by, right? So what else more can we do? Okay, let us see df, that is data frame, and I can say country region, please give me the data for all the countries, right, and their value counts. So what is the value of every country here? So China 2376, Canada 102, 1080, United Kingdom has 720, and these are just counts, right? Number of times it's been repeated in a data set. So let us not do anything with this. So since we're not interested in this, what we can do, we can plot it. We want to plot value counts dot plot. I can plot, and I can give kind as bar, and I can give the fixed size as 50, 10. Alright, so it is the width, 50 is the width, and 10 is the height. Now we can see country-wise distribution. Now you can see this is country-wise distribution. So we have all the countries. China is there, France is there, United Kingdom is there. So this is how this COVID-19 is distributed along all the countries, right? So we can see many different things right here now. Okay, let me fire it up again and go back here. Alright, so let's wait for the output. So output has come. Because the data is too huge, so let me show you the length of data frame country wise, and I want to get unique values. Country so I can find the unique, right? .unique. So if you want to find the unique value, so it's not find unique, it's not going to give us anything. Alright, so let me find data frame. Please give me my data frame. Please give me number of deaths, right? And please give me the number of deaths dot max, right? Which date or which cell? So 13,915. You can see other maximum number of deaths, and if you want to see which country has deaths, right? So you can say I want my data frame to give me deaths, right, and where deaths are equivalent to 13,915.0 maximum 13,000, or we can say df deaths. So let me show you. So we're getting it right here. So let's say df dot deaths is equivalent to, so we're getting all here actually. 31 df. So let's say df deaths is equivalent to, so you can see we are getting some output right here, but geographically I need to see that value as well. So what is, which country is this of? So let me do this. So df deaths is equal to 13195. So let me apply multi-dimensional array and say df, and let me see out of the data frame 13915. So we know now, we can see that it is Italy. Italy has the latitude and longitude this, and confirmed we are having this, and recovered we are having deaths, we are having 13,915. So the number of deaths we had, that max number of deaths 13,915, and 13,915 actually belongs to Italy, right? So we were able to extract that, right? And 444 deaths were the minimum. So let's see, was it 444 minimum? What was minimum? I don't know. Yeah, minimum is 0.0. all right, so we had to see that 444, yeah, it was confirmed minimum, right? It was not deaths minimum, It was confirmed, CONFIRMED. So confirmed minimum, we are having China, and states, some provinces are there, confirmed 4044, right? And here we can see that that's dot max. We can do this also. Yeah, we can say is equal to 13,951. Was it 3951? Yeah, I don't remember it. What was it? Max 13,915. No, 3915. It belongs to Italy. So far, right? So you can see that we have maximum number of deaths 13,915. That belongs to a country, Italy. 444 belongs to a particular region of China, maybe, who knows. Yeah. So now let me introduce you guys to, let me see what time is it. So we still have good amount of time. Oh, it's already been 46 minutes. Okay, let me wrap it up quickly by introducing Geopandas to you. Now what you need to do geographically, what you need to do if you want to use Geopandas, you will go to Anaconda Navigator, right? You'll go to environments and not installed environments, and you can search for Geopandas, because it's inside installed for me, but for you it's going to be not installed. So Geopandas is here, and click here, check Geopandas and apply. It will download the library for you. It's not going to take too much of time once the library is downloaded, right? So what you need to do is you need to incorporate. Now what is Geopandas? Geopandas is basically it converts our own data frame to geographical data frame. Since we know that we have latitude and longitude are going to give us geo points, right? And then we are going to see the scatter plot, right, as per the province and as per the country. Right, so for that we will be using Geopandas, and then once the installation is done, you can say import Geopandas. You'll say import Geopandas as GP in Geopandas, right? So I'll import. So for you it will not be imported unless you install it, or you can even run a pip install of Geopandas. I'm not sure. Let me try. If I run pip install of Geopandas, yeah, I know that, yeah, requirement already satisfied, it's already installed. You can run this as well, but this is the most secure way, because since we do not have high-speed internet available in Jammu and Kashmir, so all the students of Jammu and Kashmir can install Geopandas from here. And once we have imported Geopandas, what we can do right here after importing Geopandas, right, so let me check what is available with Geopandas. So I'll say dir, give me all the directories of Geopandas, which is GP. Okay, now we have geo data frame, we have geo series. We can convert our data frame DF to geo data frame, geo series, bulletin cast, and whatnot. We can convert it to many different things. All right, and let me go ahead and create a data frame and convert our data frame to geo. So I'll say GP, right, Geopandas data frame. So now I'm converting my Geopandas data frame, and I've imported Geopandas as GP. So I'll say is equal to GP. You know, we do PD dot data frame. Here we'll do GP dot, right? And that is going to be, I'll copy this. I'm converting it to geo data frame. I'll say geo data frame, and it takes the data frame. In our case, that is DF. Right, so in our case the data frame is, oh, the file is too long. So in our case the data frame is PF, because we already did pd.read CSV at the beginning. So I'm going to give this, and we are going to add geometry here, right? So it takes geometry, converting to geometry, and this what this geometry does, it takes points. Points are going to be two, the latitude point and the longitude point, right? So I'll say geometry is equal to GP, which is the Geopandas dot points. We have 2 points, x axis and y axis. I'll say points from, and we have x and y, and we are going to get it from data frame, which is, I don't know, what is that, lat and long, maybe, I don't know. I'll have to check it out, so please pardon me. So I'll say df dot head 1 just to check the column names, right? So it is, yeah, lat and long. So first we will be having long. Always remember that GP points from XY will take long and lat as parameter, not lat and long as parameter. I repeat, geodata frame is going to take your data frame, and out of the data frame, what do you want to take as geometry? I want to take lat and long, and those are going to be treated as X and Y values. So I will just hit OK as expected error. And we have df.lat. See, df.long is here. GP is Geopandas, POINTS from. We have our OM, X and Y. DF is here. And we have geometry spelling, GEOMETR with geometry spelling mistake, and it's done. It will work as it is. No, it'll work just like a normal data frame. For example, if I say now this geodata frame dot head, if I do this, so it's going to, sorry, look what I do. Head is going to be same as it is, right? Lat long is going to be there, but it's going to have geometry point of every single latitude and longitude, and otherwise rest of the data set will remain same, so it will not have any difference. You can handle this, but yeah, because we want geographic locations, so that's why we have to get it right. So let us see the type here, because if I say type, please show me the type of data frame. You can see the type of data frame is pandas data frame, right? But if I say show me the type of GP data frame, you can see it's Geopandas data, geo data frame, right? So that's the difference between the normal data frame. Let's plot it. So I say geo.plot. I want a scatter plot. Now you can see the geographical distribution on the map size. So I'll say figure size is equivalent to 30 by 10, and let us see the geographical data points. And GP data frame dot plot FIG size, I always forget this, is equivalent to sign. Now we are having, so this is a number of cases around the globe. So this is your geographical data points. Now what we need to do is we need to get a map here, right? We need to impart and we need to paste a map here and show these data points, show the scatter plot data points over a map, because we have map also available, or map functionality also available with Geopandas. Let me give you a rough idea. Now you can see the map is already here, right? We have seen this, right? So the line is drawn here. So the map is also, we are going to import the same kind of map here. Alright, so the site here is COVID19india.org. If you want to do analytics on this, the data frame is open source on GitHub. It's already available on GitHub. Website is covid19india.org. You can go to the website and download the dataset and start doing your analytics. And we are going to import the same world map here. And after putting the world map, we are going to show the scatter plot, and we are going to see the distribution of COVID-19 across all the globe, right? So let me know down in the comment section if you want any updations or if you want anything else. Like I was preparing that analytics and analysis over and I was doing comparison over Spanish flu 1918 and as that of COVID 2019. But yeah, I still wonder after completing the second part, right? So because now we are going to put map and do more analytics, but it's already been almost 1 hour since we've been learning this. So I'll just conclude the video here, and you guys just wait for part number 2, right? Eagerly, until the time I upload part number 2. Practice this and see what you can learn from this, right? And let me know down in the comment section if you have anything that you want, especially to be, you want any data analytics of any data point, like we have Ebola is there, or anything that you want, right? And you can try it yourself also. I want you to try it on this Indian data set, right? So download and try it on Indian data set, and I wish you all the best. Do download the data set, which is the CSV file. Do download the CSV file down in the description section, and you can also download the sketch which will be available down in the description section, right? So till then, see you, bye bye, take care.